Here we go. By the end of this lesson, you'll know the difference between a converging and diverging lenses, how to draw ray diagrams, how to describe the characteristics of the image, and how to use the lens maker's equation in magnification. Here we go. So, based upon what we've done with prisms, is this going to bend away or towards the normal line? From air to glass. Low to high, fast to slow, bends towards the normal line. Going from glass to air, high to low, high to low, slow to fast, and bend away towards the normal line. This bent which way? Towards. This is going to bend away. Good. Away from the normal line. Good. Your prism. Okay. So this one's going to do, right? Same idea. Okay. Do we see how this converging lens has some similarities to those two prisms arranged this way? Skinny on the end, fat in the middle. Good? Okay. So, based upon your exploration with the optical toy box, this thing's going to do something like that. Yes? Remember that? Friday? Maybe we did that. This is known as the focal point. This is where you can start fires with a magnifying glass. Yes? If you haven't done that, I'm sorry. It's a deprived childhood. Go out with a magnifying glass and the sun and burn something you don't care about that you can put out easily. Yeah, good. Okay, this is known as a converging lens. And it makes the light rays converge. Okay? All right. To take notes on this, you're going to want to recreate this if you haven't printed out the notes. You are going to want to recreate this. Make sure when you're making this, this is equal distance from the lens to the focal point as it is from the lens to the other focal point. Okay. And draw your object far away from the focal point. Okay. All right, so you have two focal points. One, because the first one, parallel light's coming in, it's going to go this way to the focal point. The reverse is true. If you have it coming in, it's going to go to the focal point. So there's 2 focal points. Here's your object. This is what we're going to be looking at. Don't draw this next part thing. Okay, I'm always going to be focused at the top of the object. The top of the object is going to be reflecting light in all directions off of that. Don't draw that. Okay? I just care about 3 of those rays. Okay. The first one. Now you need to start drawing this. Sorry. This is principal axis. That line there. Okay. We're going to draw parallel to the principal axis. It's helpful if you have a straight edge. And then it's going to refract where is it going to go? It's going to go, these guys are on parallel to the principal axis. It's going to go through the far focal point. Go through the far focal point. Good. To do the second ray, what you're going to do is we're going to do this in reverse. So if I shot a laser through this focal point, how is it going to bend when it goes to the lens? It's not going to go to that point because it's not going parallel. It's going to refract parallel. It's going to reverse that path. Okay? So I'm going to use that idea, and I'm going to go through the near focal point and refracts parallel to the principal axis. To the near focal point and then refracts parallel to the principal axis. Good with that. Third one's the easiest. This goes straight through center. Always start at the top of the object. Straight through the center. Hopefully, if you drew it right, they're all going to intersect at the same point. This is top of the image, point of the intersection. Because we started at the top of the object, this is going to be the top of the image. And what that's going to mean is this is an image. And we would describe the image as upside down or right side up. That's upside down, so we're going to say inverted. Is it bigger or smaller than the object? Is the image bigger or smaller than the object? Smaller. So we're going to say it is shrunken. And the third characteristic, which you have never heard of, is real. This is the light rays actually intersect. The light rays actually intersect. You have a real image. Not have a magnifying glass on your yes. So you can get rid of the baggy on inside. Those out. Not have magnifying glass. Okay. Here's what I want you to do. I want you to take a piece of paper. You don't have to rip anything out. Just hold up your notes or something. Okay? And I want you to take your magnifying glass. I need you to hold it. Okay, so you're sitting. I need you to rotate your body and legs facing that wall. Take a piece of paper, whatever it is, hold it up. Take your magnifying glass, so paper in the left hand, magnifying glass in the right hand. I need you to move it back and forth until you see an image on the piece of paper. Tell me what you see. How do you describe the image?
Upside down.
Upside down. Is it bigger or smaller?
Smaller.
Smaller. And the fact that you can project it onto a screen means it is real. This is real. Everybody good? Okay. Everybody get it? Okay. So, what you're seeing is
I see it. I see another one. The one that breaks
see the arrow upside down right there. Makes an image. Okay. So, real means can be projected on a screen. The light rays are actually doing that. Get there? Okay. Hey, follow-up question. question? Did the image form at the focal point? Did the image form at the focal point? Did not form at the focal point. That is a popular misconception. The baggies, we're gonna throw away the baggies to the boxes. I don't. We just got throw away the baggies. But we'll keep the boxes. Don't put them away yet. I got one more. Around the baggies.
Is it burnt?
You can see them all the time.
Oh, wait.
All right.
Wait, I want to put it on you. Well, like,
Okay, you're gonna redraw. Do another one. Make that. So, you're putting the object within the focal point. Okay. If you're redrawing it, make sure the focal lengths are the same. Give yourself some room over here on the left. Okay. So you're redrawing that. Are we good? Oh, you guys are so cute. All right, give your first one. First red. That'll do. Good? Okay, goes parallel to the principal axis, then through the far focal point. The second ray is a little, as we go through the near focal point, we miss the lens entirely. Okay, broken, we can't do it. All right, so here's the idea. Light's coming off of this in all directions, yes? I just want 3 of them. I want one of those that has the ray as if it was coming from through the near focal point. And that's going to refract parallel. Okay, I want the one that, like, So if you like have a straight edge, you're gonna connect that all the way through. Does that make sense? And then that goes parallel. And then the third ray, go ahead and do that. Third ray. Straight through the center. Do those rays intersect? Oh. Whatever do we do? So if rays don't intersect, then extend the refracted rays backwards. And extend the refracted rays backwards. Okay. Which is the refracted ray, A or B? B. So I'm extending the refracted ray backwards. Good with that? Okay. Which one's the refracted ray, A or B? B. Extend the refracted ray backwards. That did not work out great. This is why you use a straight edge, kids. It's pretty handy, does not go well. I'm gonna modify that tad bit. That's the path it should have been. That's looking a lot better. Okay, if you did it right, and then the third ray, that's easy. Just extend that backwards. Hopefully they intersect in the same spot. So here in this general region is the top of the image. So, image you describe as upright or inverted? Upright, shrunken or enlarged? Enlarged. And it is virtual. What does that mean? That means the light rays don't actually converge, but your eyeball is a lens in and of itself, and your brain and your lens put it together so you see an image. Okay? And this is what we use a magnifying lens for. So take your lens, magnifying glass, and bring it closer. Like put the object closer. This is like why we use a magnifying lens. Okay? So the object we're looking at is closer than the focal point, and our brain, even though you can't project this onto a screen, your brain puts it together and puts it on your retina. because your eyeball is a conversion lens. Good with that? Okay. Good? All right, so this is the second type of lens. Oh, that was silly. All right. Okay, based upon prisms, this is gonna refract this way, then that way. This is gonna refract that way, then this way. Yes? Divergent lens, you see the similarities here. Fat on the end, skinny in the middle. Okay. So this is gonna make the rays diverge as if they're coming from a focal point, rather than going towards diverging away from the focal point. Good with that? Okay. That for a divergent lens. When you're doing the ray diagrams, the roles of near far focal points switch. So one, go parallel the principal axis. And then refracts from near focal points. So parallel the principal axis. And then it diverges as if it was coming from that focal point. From the near focal point. Two. Going towards far focal point, and then refracts, bless you, parallel the principal axis. This one's probably good to be a straight edge. Okay, so that's going as if it's shooting at far focal point and then refract parallel. third one still goes straight through the center. Okay. Do the light rays converge? Do they intersect? Nope. See if you can figure out, if you have a pencil, see if you can figure out where the image will be formed. They see these around. Yeah. So we need to extend the refractor rays backwards. This one's nice. It just goes along, the red one goes along this line. The blue one extends back parallel. And the green one, well, the green one's just there. It's nice. So, point of intersection is right here. Your image. Write down the three characteristics of the image. Upright, shrunken, and virtual. Okay. I have a limited number of the divergent lenses. Pass that around. If you have one in your row, pass it, like look through it, pass it forward. Look through it, look at the image, pass it forward, or pass it back depending on where it is. Everybody in a row. You're able to see it.
Yeah.
I'll make it once.
Okay. So what you see is hopefully upright, shrunken, and virtual. Okay. First hour, someone asked a question, which type of lens is a peephole? Like in a hotel door? Or like the door of... I thought that was a very great question. So the image, when you look through a peephole, what do you see? Is the object, or sorry, is the image upright or inverted? Hopefully upright. It'd really be confusing. Okay, is it shrunken or enlarged? So which one, what we've seen so far, which one produces that? Divergent lens. Okay, good with that? Okay. So those are your ray diagrams. A divergent lens will always form a virtual image because it's causing the rays to diverge, not intersect. Okay? All right, there's some math with this. Okay. I will give you, there's a sign convention right here. I will give you the sign convention on the worksheets and on the test. And the object distance. So these are all distances. All right, so this is the Lensmaker equation. It's 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length. So this is object distance, image distance, and focal length. All distances are measured from middle lens.
I can see you.
Okay, so object distance DO, image distance DI, F focal length. We're measuring these from the middle lens. The other equation is magnification is the ratio of the heights of the image compared to the height of the object. So like when you're using your camera and you zoom in, you get like 2x. That has magnification of 2. That makes sense? Like your image is twice that of your object. Okay? You can calculate that by the negative image distance over the object distance. Okay? So this sign convention, if you have a converging lens, it's positive focal length, diverging lens has a negative focal length. Real image, you have a positive image distance. It's virtual, you have negative. If you're upright, you have a positive magnification and positive image height. If you're inverted, you have a negative magnification and a negative image or image height. Okay? So when doing this equation, this has a similar feel to, remember, the total resistance in parallel. The 1 over R is equal to 1 over R plus 1 over R plus 1. Same type of thing. Use that reciprocal button like crazy. Okay? If you are given a number, you must assign a positive and negative value to it. If you are looking to solve for that, then leave it positive, and it'll come out in that. Okay, so you have a negative divergent lens. So you have 1 over object distance plus 1 over image distance is equal to 1 over focal length. Has a focal length of 50 centimeters. You could either convert that to meters or leave it as centimeters. If you express your answers in centimeters, just for consistency's sake, I'll convert it because we've always have been. So it is 50 centimeters. I need to assign a positive or negative to it. The focal length, right here, it's a divergent lens. So I'm going to assign a negative value to that. Okay. And what is the image distance if the object is 80 centimeters? So that is 0.8 plus 1 over di So I'm gonna bring that over. So I'm gonna go -0.5, inverse that, or reciprocal of that, minus 0.8, reciprocal equals -3.25. Image distance, I need to find the reciprocal of that. Hit that button again. Find that to be 0.308. So 30.8 centimeters. And the fact that it is negative means what? Your image distance is negative. What does that mean? It's a virtual image. Your ray diagrams and your math should always agree. Okay? Your worksheet that will be due on Wednesday, along with a lab quiz, so you know that's the thing. Next Wednesday we have finals.
I didn't see anything.
Yeah.
I'm trying to.
All that.